Hey everyone. So in this video, we will talk about verification of convolution properties. So as you all know in the subject, convolution can be linear convolution, convolution can be circular convolution, but both linear and circular convolution satisfy all the commutative, associative, and distributive properties. Okay, so we will not complicate things by trying to do convolution linear or circular without using the function or anything. I will use here the ready function conv. Okay, you can see I have removed the colon here. Let me put the semicolon and this error map will go. I want the answer to be displayed automatically as and it's calculated. That's why I thought let us remove this thing. Okay, so what are the properties of convolution? So the properties of linear convolution include first one is commutative. Commutative in the sense you take x1 and convolve with x2, or you take x2 and convolve with x1. Both of them are going to give you the same answer. Fun, right? A plus b is equal to b plus a. Is a multiplied b by b is equal to b multiplied by a, right? So addition operator, multiplication operator also satisfy the commutative property. But is a minus b same as b minus a? No. A divided by b, is it equal to b divided by a? No. Okay. So all operators need not satisfy this particular properties. Thank God, convolution operator does. Okay. So the first property is commutative property, that is x1 convolved with x2 gives you the same answer as x2 convolved with x1. Then there is something called as the distributive property. If at all take x1 and x2, you add them first and then you convolve, or you convolve them individually and then you add. That is okay. So both of them are going to give you the same answers, right? So this is the one, the not so efficient implementation. You can see you have to convolve this and you have to convolve this, then you have to add. Convolution involves lot many multiplications and additions. So this is, so what they say is the distributive property says that you think clever, you add them first, then you do the convolution. You can reduce hell lot of multiplications and additions. Okay, so that is the the importance of distributive property, and of course convolution satisfies this particular distributive property, right? It's a cool property, I guess, because it saves you the lots of time and power. Okay, then there is something called as an associative property. What it says that this property says that if at all you take x1, you convolve it with x2, and together the answer you convolve with another sequence x3, then again, if at all you take sequence x2 and x3, you convolve them first, and then you convolve with x1. Both of them are going to give you the same answers. So that is, uh, associative property. Okay. So not that the sequence is important. You take x1 convolve with x2, then you convolve with x3. Okay. There are operators which need not satisfy this particular property. Okay. So you take x1 and convolve with x2 convolve with x3. Both of them give you the same answer. So these three properties. Now, how do we verify these properties? Okay, so you want one of them on the left hand side and one of them on the right hand side for the comparison. So first thing is that you need here how many sequences? X1 is there, then there's X2, and for these two properties, you also need a X3. Okay, so that's why what we will do is first let us read X1, X2, and X3. Okay, so I always encourage every programmer to make their program interactive, as much interactive as possible, and one should not be encouraged to get into the program to give the inputs. So let it be interactive. So first what we'll do is we'll take x1, x2. That's the variable name I'm giving for convolution of x1 with x2. X2 and x1 is the name I have given for the convolution of x2 with x1. As I told you, conv is the ready function that I am using. Okay, actually what you are supposed to do is you are supposed to do this without function in case it is asked in exams. Anyway, so let me have the plots of individuals. So let me run this thing. So what I will do, I will just plot them one besides the other, because if at all see it for yourself, both the graphs, you will be sort of convinced. But actual thing is this. Okay, you can compare. So this one is x1, x2, I can compare with x2 and x1 using an if statement. If they are equal, then the property satisfied is what I'm going to display. Otherwise, the property is not satisfied. That's what we will do. We'll have a display. You have display of the answer also. Let me run this thing here. Okay. So I'll select these lines and I will run these particular set of lines only. Okay, let me read for the time being all the three sequences. Okay, so here you can see it's waiting for the input here. So my first sequence is, I'll give something simple, 1, 2, 3, 4. That's my first sequence. Let me give some second sequence, 1, 2, 1. Okay, and the third sequence. And you can see here I'm giving them in a square bracket. Okay, I'm giving them in a square bracket. I do not want any confusion there. Okay. So one more piece of advice that I want want to give you is you should be able to solve these numericals in the notebook. Okay. So MATLAB is all about that only. You should know what you are trying to do. Then only it's going to be easy to be able to verify whether you have done this correct or not. You better solve it on the notebook, the same problem, the same numerical, and you get it correct on the notebook. Then come to the MATLAB for verification. Okay, you can see here x1 convolved with x, you give my an answer 1, 4, 8, 12, 11, 4, and x2 convolved with x1 gave me 1, 4, 8, same answer, and then the equality satisfied, and there I have a commutative property. I also have a graph here. I also have a graph here. So let me take you there. I don't think it's necessary for the timing. Okay, now let me go to the second one. Once I am done with this commutative property, let me go to the second one. So here what I have done, so which is the property, distributive property. So for this, what I have to do, first I have to add two sequences. First I have to add two sequences, then I have to convolve with the third sequence. So here you can see I have made this one statement here, 0 pad inputs to maximum sequence length. Okay, so whenever I am adding two sequences, say my first sequence, when I ran the program, I gave my first sequence as what was that sequence. So let me take you to the input. See, I see here the first sequence is 1, 2, 3, 4. Second sequence is 1 to 1. I think I may be in trouble here because when I'm adding, the matrix dimensions do not match. Shall I try this piece here? Wait a second. Let me run this. Yes, so I have an error. So in this particular program, there is a small requirement that when you give the inputs, you better have the same sequences. All sequences should be of same length. Okay, that's a catch. Okay. Anyway, let us see this piece. Okay, so what you are supposed to do here is first add two sequences. Add two sequences. So to be able to do this, you better have both sequences of same length. Okay, add the sequences, convolve with the third one. You can see here, added two sequences, convolve them with the third one, give it some fancy name, then convolve individual sequences, then add them. See here, convolving individual sequences, x1 and x3, x2 and x3. Then I have added them. Then again compare, you can see here. Okay. So I gave this name distributive for this particular sum and I compared, and you can see the equality should be displayed. Okay, so similarly for the third case, here what I have done is x1 and x2, which is what is this particular thing, x1 and x2, it is x1 convolved with x2. Now since I had calculated this x1 convolved with x2 already here, so you can see x1 x2, where is this x1 x2? Once again, wait a second, x1 convolved with, I see, okay, see here, x1 x2 I already have calculated in this particular piece, right? I have already convolved x1 x2 and I've given the name x1 convolved with x2, given the name x1 x2, x1 also I have. So that's why this ready result I have used in particular. You can do it anyway, it's no big deal. Okay, so you can see x1 convolved with x2 has been convolved with x3. You can see this is the first operator, which is convolution of x1 with x2, which we have calculated already. And this is the third operator, second operator, sorry, and x1 with x2. This also I had calculated over here, and here also I have done this particular thing. So as I told you, there has been a confusion. So let me run the entire thing once again, so that this time I give all three sequences of same length. Okay, so here let us go to the command window. Enter the first sequence. I'm redoing this once again. Should I have a CLC? Wait, let's go ahead here only. 1, 2, 3, 4, 5. That's my first sequence. Second sequence. 1, 2, 1, 2. Do not give big sequences. You should give some sequences which you can calculate on your notebook also. Okay, I have some sequences, and you can see individual messages are getting displayed here. Okay, screen share. Wait a second. That's this graph that has popped up. Let me show you. Okay, so this graph, there's nothing much in this. So it is only, graphical depiction. Some like, you'll be happy. Yeah, they look similar. Actually, it's a very bad practice because accuracy is not in this particular graph. Because first thing first, the answer should have started from 0, but it's just an indication that you may be correct. Okay, so I do not suggest graph. For numerical value should be sufficient. Okay, one second. Be there. Screen as yeah. Okay, so you can see here which are the properties that got satisfied. The 1 second here. Yeah, so you can see the distributive property got satisfied. Associative, the commutative had already got satisfied. The distributive property satisfied. The answer has come. Then associative, x1, x2 convolved with x3, x1 convolved with x2, x3. You can see both of them give you the same answers, but this was the catch that you used an if statement. Okay, so what can possibly go wrong here in this particular program? So program is tricky. So possible thing that may go wrong here is you end up giving different lengths of inputs and then have a matrix dimension mismatch error. That thing can happen. And then there are lots and number of variable names. You give proper names that at least you understand. Okay. Then comparison. Sometimes what happens is you are single equal to sign and you do not get this thing. You forget to give an end or else. Okay, that can happen sometimes. Okay. Otherwise, I think this should be fine. One more problem I see whenever you are doing the same thing. Okay, now the same properties are satisfied for circular convolution also. So then in that particular case, what you are supposed to C, C, O, N, V, and then you have one more term. You not only have the first sequence, second sequence, and third sequence, you also have, along with that, you have an N. N is endpoint circular convolution. Here also, let me tell you, the value of N has to be same throughout. Okay, zero padding, it will take care automatically. Or I would say, do not take risk, give all of them equal length and value of N also same. You should be fine. Okay, so that was about the second program, the properties of verification of convolution properties. As I said, it's very important for you to be able to solve the properties on the notebook and then verify it with MATLAB. Thank you.